We have a transformer. This is a Tamagawa transformer. 110 volts to 20 volts. So it is a dual voltage supply. We can use 110 or 220 volts. But for our project, we're going to use the 220 and 0. This blue and black. This is the primary. 100% pure copper wire. And then for the secondary, we have the 15 volts, 0 to 15, 0 to 15. So this is center top. 0 is the white, red is the 15 volts, 1 ampere. So the current rating is 1 ampere, 15 volts. Secondary, from 220, it will stepping down into 15 volts. RMS, root mean square. So we're going to use the 0 to 15, only these two lines, 0 to 15. Because we're going to make a halfway voltage doubler. 220 for the primary and then 15 volts for the secondary. Primary 220, 15 volts secondary for this transformer. Have the plug for the 220. So I'm using the 220 blue and then the 0 black. 220 primary, secondary, 15 volts. Step down transformer. We're going to plug it to 220. So this 220. Let us plug it to 220. Okay. Now we're going to measure the voltage into the secondary. So this is 15 volts only. So that's why it's and we're using a transformer. And it is okay to touch the wire because it's only 15 volts. So let us see if this is 15 volts. We're only using the two wires, 0 volts and 15 volts. We're going to measure that. What is the voltage at the secondary? 15 volts. It is AC. It's still AC. So from 220 volts, it becomes 15 volts AC. So we set the tester to 220 volts AC. Okay, AC. And then let us measure the so it is 15.3. So you can see here it's 15.3. So again, this is AC. What if we're going to change the probe? Still 15.3 because the secondary is AC. From 220 volts, it becomes 15 volts AC or RMS, root mean square. And we're going to make a half wave voltage doubler. We now have the components: electrolytic capacitor, 470 microfarad, 50 volts. And then we have two capacitors. Also connected is the 1N4007 power diode. And with the use of transparent type breadboard and jumper wires. Okay. This is now the voltage doubler circuit. We're going to use this circuit for the transformer. So we can connect now the transformer to the input of this voltage doubler, and we're going to measure the output into the one capacitor. So this is halfway voltage doubler together using with transformer. Now that the transformer is connected to our circuit, we're now going to measure the voltage output using, again, pros kit, the tester. So 220 volts becomes 220 volts AC, alternating current becomes step down, 15 volts AC, alternating current. And then what is now the output of the circuit? Is it AC or DC? It is DC. And the voltage is, we're measuring it to the one capacitor. .3. So this is AC, DC. How about DC? Is there any? For AC, there's no voltage. For DC, .2 volts, and the input since our input is AC, 15.2 volts AC, and the output DC. Hey you. And the output is DC. 40.3. So from 15 volts alternating current into 40.2 volts AC, DC. Direct current from AC to DC. So it is almost doubling the voltage from 15 volts to 40 volts. Almost. So that's why it is called voltage doubler from AC to DC. 15 volts to 40 volts DC. This is now our circuit, the schematic diagram of half-wave voltage doubler. Figure 1, voltage doubler, half-wave with transformer. So where is the transformer? This is the transformer. Okay? Primary 220 volts. If this is 220 volts AC, this is the waveform. AC. Positive, negative voltage. Reverse voltage. And then the secondary. Since this is step down, it becomes 15 volts small AC. From big AC, big to small. From 220 volts AC to 15 volts AC. And we're using 0 volts to 15 volts to the transformer. Because this type of transformer is center tap. Primary, secondary, from big AC to small DAC. This is the capacitor. 470 microfarad, 50 volts. Why are we using 50 volts? Capacitor. Because we are making a voltage doubler. It means 15 volts can be 30 volts or more. So we're using 50 volt. And now we have this diode. 1N4007. 1N4007. Then another capacitor. This is where we get the voltage output. So during the positive half cycle, since this is alternating current, forward voltage, and then this one is the reverse voltage. Forward, alternating forward, current flows into the transformer, and then it will flows into the 15 volts and becomes now 15 volts AC, and then it flows into the capacitor. This diode is forward bias, so the current flows here, then goes back to the 0 volts. Here the current will not flow here because this is reverse bias. Only the current flows in one direction at the diode via anode to cathode, A to A, anode to cathode. But here this is cathode to anode, so it is reverse. It means it is open. So the current flows from capacitor, charging the capacitor with this diode. And this one is open. And then during the negative or the reverse, since this is positive, the first initial voltage current flow, now it reverses direction. From this direction, now the direction now goes in the counterclockwise direction. So this now becomes positive, this one is negative, counterclockwise. So this diode now is reverse. So this is open, then the current flows to the capacitor, and then charging this capacitor via this diode. So this diode is forward bias because the current flow now is in this direction, reverse. It will not flow here because reverse bias, cathode to anode, because current only flows in one direction at the anode to cathode. So this one flows here, charging the capacitor with this diode. And then what is now the voltage output? It is the voltage at the transformer plus the voltage at the capacitor, twice of the voltage input. So the voltage here, voltage at C2, is equal to twice ng voltage at maximum or this transformer voltage. No, this BC2 twice ng BM or BM plus voltage at C1, because these two will add the voltage at the capacitor and then the transformer will add BM plus BC1, and it becomes now the voltage across the output, twice the voltage. But in our situation, our input voltage is or BM maximum voltage or peak voltage is 15 volts, but the voltage output is 40.3 volts. So what happened? Because the output voltage is not regulated. That's why supposedly it should be 15 volts times 2. 15 volts times 2 should be 30 volts because voltage, it is voltage doubler. But because of it is unregulated, it means from this AC, it becomes now DC, straight line in one direction, DC. That is now the voltage, and it is not regulated, so fluctuating. There is a tendency to become 40 point something or more, not 15 volts. There is a ripple voltage into the output, but still it is in one direction. That's why they call it DC. So from 220 volts AC, it becomes 15 volts AC and now becomes 40.3 volts DC. So this one is alternating, big alternating current, and then small step down, and then it becomes straight or one direction DC. So this is a 0 DC with the ripple voltage. So this ripple voltage can be eliminated using high value capacitor. So if we are going to use for example 1000 microfarad instead of 470, it will smoothing or eliminate this ripple voltage into the top of the DC. So in short, from alternating into direct current, DC, positive, negative. Negative is connected here, and positive, this becomes now voltage DC. So voltage doubler, why is it called half wave? Because we're only measuring the voltage across this capacitor, the sum of the two voltage from the voltage peak of the transformer and then the voltage of the first charge capacitor. So charge capacitor plus the voltage of this transformer will have this twice voltage peak. We can solve that using a Kirchhoff's voltage law, KVL, using KVL. It is BM, voltage maximum, plus voltage at C1 minus voltage at C2 is equal to 0. Sum of all voltages in a closed loop is equal to 0. Okay? And then using that formula, so voltage at C2 is BM plus BC1, or Since BM is equal to BC1, it becomes twice of BM or double. But it is not double because the output is unregulated. It varies. Going to connect this homemade module to our transformer. Now measure the voltage. Set the tester to DC 200 volts. 200 volts DC. For the input, AC. We have no input. $15.8. $15.8, and it is not regulated. For the output, it's DC. Set that 200 volts DC. It becomes now 41.1. So you can see the polarity negative, so the positive must be here. 41. So this one is the positive. 41 volts. Negative. So this one is the positive. Okay? So this is now our module, voltage doubler. From 15 volts becomes 41 volts DC. 15 volts AC becomes 41 volts DC. Let's go back to our design. So here, this is positive and negative. So from our actual positive, negative, same wirings. And for the schematic, this must be positive, this one is negative. Positive, negative. For the output, positive here, negative. Because we are following the polarity of the capacitor. Must be positive here, negative then. Okay? The polarity of the capacitor. So as the actual wirings. Same as the module. Positive, negative.